Welcome everybody to the second annual Mathematical Geometers. Today, we are learning the rules of exponents with our distinguished guest, Robbie Platten. Thank you for having me today. So we heard from our scouts that you are a new geometer. Yes, I started like 2 to 3 years ago. I really like being a geometer, but my real passion is being a luchador. Very interesting. Well, I know we just started, but we do have to take a quick commercial break. But when we come back, Robbie Platten will tell us about how to multiply and divide geometers. Multiply and divide exponents. Everybody, welcome to Billy Bob's Emporium. We have a new merchandise opportunity. We've partnered with WWE to sell Rey Mysterio masks. Go online to buy yours at BillyBobsEmporium.com. Okay, welcome back. Would you like to tell us about multiplying and dividing exponents now, Robbie Platten? Sure. I even have some examples to explain it and show it all to you guys. I do have it down here though, so if you would like me to explain, we have two examples. One is x to the 47th power times x to the 37th power times x to the 777th power. And the other one that we have is y to the 27th power times 6 to the 7th times x to the 6th power and y to the 78th power times x to the 999th power, y to the 92nd power, and x to the 565th power. Wow, that's fascinating. Would you like to tell us how to solve these examples that you've given us? Yes, the first example, we'll look at the first example first. It's pretty easy. All you really have to do is add the 47, the 37, and the 777 to get your answer of x to the power of 861. Well, that does make sense. But what if you had more variables than just the one variable times one variable? Or in this case, the same variable times the same variable 3 different times. What would you do in that case? Well, I was getting there. If you just let me look at the second example I had, I can explain it to you. Okay, the second example was y to the 27th power times x to the 6th, y to the 78th power times x to the 999th power, y to the 92nd power, and z to the 565th power. Which by solving that, all you really are doing is doing 6 plus 999 to get the x exponent. Then you would do the same thing for y, which would be 92 plus 78. Lastly, you would just move the z to the end, which would give you the answer of x to the 105th power, y to the 107th, and z to the 565th power. That is how you do it with multiple different variables. Well, that's wonderful, but we do have a guest who wants to know more about dividing exponents instead of multiplying exponents, because they've got the multiplying down, they just need to know the dividing of said exponents. Can you explain that to him? But first, everybody welcome the guest that we're talking about, Snowball Sam. Well, I'm learning how to divide, but the journey of trying to figure out how to divide the exponents has been pretty cold. I was wondering if you could answer the question of how to divide the exponents for me. Well, it is a great question, Sam. I would like to explain it to you the best I can. Let's do some example work. We take x to the 789th power, y to the 3,468th power, and y to the 7,988th power, divided by 234 to the x power, y to the 789th power, and w to the 568th power. By doing this, first we would do 789 minus 234, which would give us an answer of x to the 554th power. Then we do the y by doing 3,468 minus 789 to get y to the 2,679th power. And lastly, we do the w's by doing 7,989 minus 4,568. So we get w to the 4,421 power, which would give us an answer of x to the 554th power, y to the 2,679th power, and w to the 3,421 power. Do you understand what I'm saying, Sam? I think I finally understand, thanks to you, Robbie. Thank you. It finally won't be a cold journey to figure out how to divide exponents. Splendid, Sam. I'm glad I can help you so it wouldn't be such a cold journey to figure out how to divide exponents. Thank you, and we'll see you next time, Sam. But now, let's hear a thing from the host, who's supposed to tell me what's supposed to happen next. Well, I'm glad that you could help Sam with all of that, but we do have one last commercial break we would have to get through so we can fund the next annual mathematical geometers. Well, everybody, I'm Billy Bob of Billy Bob X Emporium. We have recently acquired the annually produced podcast of mathematical geometers. And because of that, we've had to get some interesting sponsors to fund that experiment, which is why we are selling Snowman Sam's hat. And we're even selling the host's glasses. Just go to billybobsemporium.com so we can fund mathematical geometry. Welcome, everybody. Welcome back to Mathematical Geometers. We're almost running out of time, so we gotta wrap up this interview real quick. So let's get into the last exponent rules, brought to you by our good friend Robbie Platten. Robbie, take it away. Okay, thank you for doing that. We do have 3 more exponent rules that we have to get through in this interview, though. And I have 3 examples for each one. We have 1 example for each one. My bad. 1 is a 0 exponent, 1 is a negative exponent, and the last one is if you had, like, parentheses, and then an exponent out here, and an exponent in the parentheses. So, for our first example, we'll do 29 to the 0 power. How do you think we would get that answer? How do you think we would get that answer, host? Not really. Doesn't really sound that cool. Sounds pretty boring, actually. You just get on with your last exponent and get out. Like, hurry up already. I'm doing them right now. Will you calm down? First, we do negative exponent, which is 5,794 to the negative 999th exponent, which would put it at the bottom of the fraction, put a 1 up top, right? And then that's what you do. You put the 5,794 at the bottom with the positive 900 exponent, because 999 exponent, then a 1 up top. Isn't that pretty cool that we can change it to a positive that quickly? Well, Robbie, wouldn't the answer to that exponent be 1? It would just be like, the answer would just be 1, right? Well, actually, it would be 0, because to show you from that example, it would practically be like there's no number there, or it's practically like 29 times 0, and then that's how you would get like your answer for that exponent rule. Do you understand what I'm trying to say, host? Well, that is fascinating. What about the other exponent rules you were supposed to teach us? Would you like to go in depth on some of those exponent rules now with those examples you were talking about? Will you shut up? I will take your advice and leave, but I'm saying my last exponent rule before that. Jeez. We're doing parentheses now, okay? So we have parentheses a to the 9th power, b to the 3rd power, times 12. We solve this by... We do that by multiplying the exponent on the outside by the exponents on the inside, right? Like, that's what you're supposed to do. Yes, we would do it like that, which would give us an answer of a to the 106th power and b to the 36th power. Everyone understand? Good. I'm leaving. Okay. Yeah, you better be leaving, noob. You don't know anything about math. You don't know anything about math or any geometers. Wasn't this show supposed to be about mathematical geometers? Now we're having a 2 to 3 year old talk about exponent rules? What happened to the mathematical geometers we were supposed to be talking about?